to record. Okay, so the trig form of a complex number, where my complex number is z equals a plus bi, is z equals r times the quantity of cosine theta plus I sine theta. Okay, which should make sense because isn't the cosine the x coordinate and the sine is my y coordinate? So A was our x at our point, cosine is the x, obviously bi is the sine I, okay? Where A equals r times the cosine of theta, B is r times the sine of theta, okay? And that should make sense to you guys because if you distribute the r through, right, okay? And then r is found by taking the square root of a squared plus b squared. And what is the square root of a squared plus b squared? What is the square root of a squared plus b squared? Wasn't that the distance of your coordinate? Yeah, the distance of your imaginary, your complex number, okay? So when we're looking at it on a coordinate plane, the r is the distance from the origin up to your complex number, right? That should make sense to you, okay? B is the imaginary, the y, going up to that, and then a, and that's where that Pythagorean theorem comes in on how we find the distance of r, right? Okay. Now, theta, again, is your direction angle from your real axis to that imaginary point, right? Okay. Now, again, the tangent of theta, how do we find tangent of theta? So a sine over cosine. So in this case, wouldn't it be b over a? Okay. And the number r is the modulus, again, which is your direction angle, right? C is theta. All right, so let's go ahead and write the complex number of z equals -2 minus 2 radical 3i in trig form. Okay, so real quick from that, can we find to be in trig form where r times the quantity of cosine theta plus I sine theta? We need to know what r is, right? So can we find my r? So we're going to take the square root of a squared plus b squared. And what is my a in this problem? -2. And what's my b? -2 radical 3. You guys okay with that? What's -2 squared? 4 plus, what's -2 squared is? 4. What's the square root of 3 squared? 3. So what's 4 times 3? 12. Good. And 4 plus 12 is 16. So what is the square root of 16? 4. So we know our r is 4. Okay. Now we need to be able to find our theta, right? Can we find our theta? Yeah, because how do we find theta? We take the tangent of theta equals b over a. Well, what's my b? What was my b? -2 radical 3. And what is my a? -2. So we know the tangent of theta is equal to just radical 3. You guys okay with that? Bless you. Okay. Now, how do we actually find what theta is? We take its inverse. Now, however, when you use your calculator here, we're going to get some crazy decimals, won't we? So let's think of our right triangles, right? We have 30, 60, 90 triangles, right? And if I have radical 3 we know is a 30, 60, 90 triangle, right? And if I have a 30, 60, 90 triangle, okay, the tangent of that is our opposite over our hypotenuse, right? Okay. And what is the theta? When it's radical, or theta is what? When it's radical 3. So let's go. I'm just going to do a random 30, 60, 90 triangle right now. So 30 is always 1, 60 is radical 3, So tangent is opposite over adjacent. So my opposite over adjacent, which one would give me radical 3? Would it be pi over, would it be the 60 degrees or the 30 degrees? It'd be the 60 degrees, right? Which our 60 degrees is just pi over 3. Is everyone okay with that? Okay. Now, however, once again, we have to think about this. What quadrant is -2 minus 2 radical 3i going to be in? Is that quadrant 1, 2, or 3? So v equaling -2 minus 2 radical 3i is in quadrant what? So it's a negative and a negative, right? And a negative puts me in quadrant 3, right? So we are in quadrant 3, right? So if we're looking in quadrant 3, we're this angle right here. So how would I actually get this angle from pi over 3? So pi over 3 is here, but we want this whole theta. Add it to, right. So our theta is we're going to take pi plus pi over 3, which ends up being what? 4 pi over 3. Is that right? Is everyone okay with that? All right. So now we have our r and we have our theta. Can we now write our form? Yes, our trig form. So our trig form coming back up here. V equals r. What's my r? 4 times cosine of theta. And what's my theta? 4 pi over 3 plus I sine of theta. And what's theta? 4 pi over 3. And this would be my trig form of that complex number. Make sense? All right. Now we're going to take a trig form and we're going to put it in standard form of a plus bi. So we're actually going to calculate what is like the cosine of 4 pi over 3. What is the sine of 4 pi over 3? Okay. Obviously, it's a little bit different here. Okay. So let's look at radical 8 for a second. Can anyone simplify the square root of 8? I don't like it even it like that. What is the square root of 8? 2 root 2. Okay, is everyone okay with that? All right. So now let's think of the cosine of negative pi over 3. So if I'm in my coordinate plane, right? If I'm going to negative pi over 3, wouldn't that be in quadrant 4? So this would be negative pi over 3. You guys okay with that? So this angle would be 60 degrees. Yes? And this one would be 30. You guys okay with that? So now if this is 60 degrees, we know across from 60 is radical 3. However, it's going down. So wouldn't that be a negative radical 3? Okay. My x-axis would be 1 across the 30, and it's positive because it's going to the right. And then my hypotenuse would be 2, right? Wouldn't it actually be -2? It wouldn't actually be positive because it's the distance. Sorry. All right. Now, what is the cosine of that pi over 3? So looking at the 60 degrees, what's my cosine? So think of SOHCAHTOA. What is my cosine? Adjacent over hypotenuse. So it would just be 1/2. You guys okay with that? Okay. Plus I times what is the sine of negative pi over 3? So what's the sine of this 60 degrees? Negative radical 3 over 2. You guys okay with that? Okay. Now, can we distribute the 2 radical 2 through? Yeah. So my z in standard form now would be what's radical 2? 2 radical 2 times 1/2 root 2. What is 2 radical 2 times a negative radical 3 over 2i? So what happens to those 2's? We know it's going to be a minus sign. It's going to be negative, right? What happens to these 2's? So we have 2 radical 2 times radical 3 over 2. So the 2's will cancel, right? And what's radical 2 times radical 3? Radical 6. So we have radical 2 minus I radical 6. Or you could write it as radical 2 minus radical 6I. So either way, where the I is in the back. Okay. Any questions going from standard form to trig form or trig form to standard form? No. Okay. Great. Product and quotient. Okay. Product. If we have 2 trig functions, Z1 and Z2, if I want to multiply them, okay, I want to multiply them, I am going to take R1 times R2, so the 2 radius, right? Okay, the distance there, times the quantity of cosine of theta 1 plus theta 2, plus I times the sine of theta 1 plus theta 2. So we want to multiply, we're going to multiply the radius, and then we're going to add the thetas. Okay. For the quotient, kind of the same idea. The only difference is instead of multiplying the r's, we're going to divide the r's. And instead of adding the thetas, we're going to, what do you think? Subtract the thetas. Yep, that's it. So cosine of theta 1 minus theta 2 plus I times the sine of theta 1 minus theta 2. And then we have to remember, Z2 cannot equal what number? What can't you divide by? 0. So we have to make sure that second trig function, complex number, is not 0. Okay. Which, why would they ask you to divide it if it was 0, right? So find the product of Z1 and Z2. Find the product. All right, so this is like our R1. Here's our theta 1. Theta, not Q. And theta 2's. Okay, and this is R2. So if I want to find the product, I'm going to multiply R1 times R2. So what's my R1 and R2? 3 times 2, which is 6. Is everyone okay with that? Okay. Then we multiply by the cosine of theta 1 plus theta 2. So we're going to multiply that by cosine. What's my first theta? Pi over 4 plus what's theta 2? 3 pi over 4. You guys okay with that? So we end up getting cosine of what's pi over 4 plus pi over 4, or 3 pi over 4. Isn't it just pi? Plus the sine of theta 1 plus theta 2, which again is just the sine of pi over 4 plus 3 pi over 4. And again, that's going to be an I, got the I, plus I sine of what? That's pi over 4 plus 3 pi over 4. Isn't that just pi again? Now we're going to do some math. All right, so now can we, okay, because we're finding the product, we actually have to calculate it, right? Cosine of pi. So if I'm thinking about my coordinate plane, pi is right here, right? What is that as a coordinate? Is that -1, 0? And what's the cosine? Is it the x or the y? So what? The x, right? So what's my x? -1. Plus I times, now what's the sine of pi? 0. So now, what do we get as a final answer? What's 6 times -1 plus I times 0? -6. Why? Because 0 times I is 0. 0 plus -1 is -1. And then -1 times 6 is -6. There we go. So the product of Z1 and Z2 is just -6. Another product. I should get a couple products. Simplify. All right, so we're just multiplying, right? So does that change with what we just did? No, just a different form. They didn't write it the same, okay? So we're gonna multiply our R1 and R2. So I'm gonna take 8 times 2, or 2 times 8, okay? And then what do I do with the thetas? Do I add or subtract them? I add them. So we're gonna have 2 pi over 3 plus 11 pi over 6. And then 2 pi over 3 plus 11 pi over 6. The nice thing, if you've noticed, they're always going to be the same, aren't they? Yeah, let me add those. I'll give you a chance to add those first. Yeah. So 2 pi over 3 plus 11 pi over 6. What did you guys get when you added those? What's 2/3 plus 11, 6? 15 pi over 6, right? So that's 15 pi over 6. But can you simplify that? How about 5 over 2? And what was 2 times 8? 16. So we get 5 pi over 2. Is everyone okay with how I added those two finding common denominators and then simplifying and dividing by 3 for there? All right, so now 5 pi over 2, where does that lie? So 5 pi over 2, because normally here's 0, pi over 2, pi, 3 pi over 2. So where would 5 pi over 2 land? Right here, right? What is that as a coordinate? 0, 1, right? Yes, because pi over 2, this would be 2 pi over 2, 3 pi over 2, 4 pi over 2. So then this one would be 5 pi over 2, correct? All right, so now we have 16 times, what is the cosine of pi over 2? Is that the x or the y? Is cosine x or y? X. So the cosine, what's my x? 0 plus I times the sine of pi over 2. And what's the sine of pi over 2? 1, right? So what would be 16 times 0 plus I times 1? 69. Yep. And there you go. There's your product. 16I. Because 1 times I is I plus 0 is I, and then 16 times I is 16I. All right. Example 5. Okay, what are we doing in example 5 here? Are we multiplying or dividing? We're dividing here, right? So same idea. The only thing that changes with the formula is instead of adding the thetas, we are going to subtract, and we're looking at degrees and not radians. Okay, but can we still do that? Yes. Okay. So instead of multiplying the r's, we are going to divide the r's. We're going to take 24 divided by 8 times the cosine. Now we're going to subtract the theta. So we're going to take 300 minus 75 plus I times the sine of 300 minus 75. Okay. So what is 24 divided by 3? Or divided by 8? I just told you. 3. Cosine, what's 300 minus 75? 225, right? Plus I sine, and again, when you subtract that is 225. Now we have to figure out what is the cosine of 225 degrees. Okay, now we want exact answers. So real quick, where is 225 degrees? What quadrant? 1, 2, 3, or 4? 3, yep. So we're in quadrant 3. So we know to get to 225, okay, from 0 to 225, we pass 180. So could I do 225 minus 180 to get the angle in between the x-axis and our line? Yeah, and what do we get there? 45 degrees. So we have a 45, 45, 90 triangle, right? And what do we know about the legs of a 45, 45? They're the same. So we have 1 and 1, and then we have root 2. However, what's my x? Is that going to be positive or negative? Negative. And what about my y? Also going to be negative, right? Okay. So let's calculate now. Cosine of 225. So what is the cosine of this 45-degree angle? Okay, and how do we remember cosine? Adjacent over hypotenuse. So it would be -1 over radical 2. However, I don't like that, do I? So how should I rewrite that? Negative radical 2 over 2 plus I times the sine of 225. And what's the sine of 225? Isn't it the exact same as cosine? And in this one, our y is also negative. So it's -1 over radical 2 or radical 2 over 2, right? You guys okay with that? And I changed the plus to a minus because that sign was a negative, right? All right, now can we distribute the 3? What's 3 times negative radical 2 over 2? Not just -3 radical 2 over 2 minus, and 3 times the exact same thing except for I is 3 radical 2 over 2 I. We need to do another product one. Are you guys okay with that? Yes, do it. Okay. All right, find the product of Z1 and Z2. Find the product of Z1 and Z2. So again, product, we're multiplying. So what do I do with the thetas? Do I add or subtract them? I add them, right? So I'm going to multiply the r's first, which is 2 and 2. And then I'm going to take the cosine of theta plus I sine of theta plus theta. And what are my thetas? Pi over 6 is theta 1, and pi over 3 is theta 2. Okay. Okay with that? So what's 2 times 2? 4 times the cosine. And what is pi over 6 plus pi over 3? Pi over 6 plus pi over 3. Pi over 2, why? Pi over 6 is 30 degrees. Pi over 6 is 60, so 30 plus 60 is 90, right? Which is pi over 2. So we have cosine of pi over 2 plus I sine of pi over 2. Hey guys, we already know pi over 2. What is that as a coordinate? Pi over 2, wasn't that 0, 1? Yeah. So what is the cosine of pi over 2? 0 plus I. And what is the sine of pi over 2? 1. So what is 4 times 0 plus 1i? So we know z1 times z2 is just equal to 4i. What is that as a coordinate? What is that as a coordinate? What would that be as a coordinate? What is my A? What's my real part? 0. And what's my imaginary part? So it'd be 0, 4. Just kind of a review there for you. Okay. All right. All right, powers. Okay. So where it gets a little more complicated here. Okay. Algebraic theorem. If z equals r times the cosine of theta plus I sine of theta is a complex number and n is a positive integer, okay, then z to the nth power, okay, is equal to r times the cosine of theta plus I sine of theta raised to the nth power. So once I distribute, could I FOIL that out that many times? Gets crazy, right? There's a shortcut for this, and this is what his theorem says, okay? To make it easier, I could just take r to the nth power times cosine of n times theta plus I sine of n theta. I don't know why I put the brackets, but that's okay. Okay. So to ease it out for you, to make it a little bit easier, you just raise the r to the nth power, and then you multiply the power to each of your thetas. Okay? Your angles. Because I would not want to take this and have to FOIL 12 times, would you? No, that'd be crazy. Or use your Pascal's triangle. Do you remember that? Or do that. I don't think you want to do that, do you? Me neither. Okay. So now, we need to, because we're in -1 plus radical 3i to the 12th power, we're in standard form. So we need to convert this into our trig form first, right? So we need to find my r. And do you guys remember how to find your r? It's the square root of a squared plus b squared. What's my a? -1. What's my b? Radical 3. So -1 squared is 1. Radical 3 squared is 3, right? So 1 plus 3 is 4. So the square root of 4 is 2. So we know my r is 2. You guys good with that? Now we also need to find our theta. And how do we find theta? We use the tangent of theta equals b over a, right? And what is my b in this problem? Root 3, sorry, over. And what's my a? -1. Okay. So again, we have theta equals tan inverse of negative radical 3. You guys okay with that? Now remember, radical 3, the tangent of radical 3, it was what? Pi over what? Radical 3 is pi over, it's a 30-69 triangle, so is it pi over 3 or pi over 6? Pi over 3, okay? All right, now, real quick, we don't go off of pi over 3. We actually have to see where we're located in our coordinate plane, right? So where is -1 radical 3 located in my coordinate plane? Where's -1, radical 3 located in my coordinate plane? Quadrant 2, right? So we know, okay, so here's pi over 3, right? But our theta is from there to there, right? So how would I actually get what theta is? What would I have to do? This here is pi over 3. How do I find theta? We know theta plus pi over 3 would equal what? Pi, right? So how would I get rid of that? Subtract it from. So theta is actually going to be pi minus pi over 3, which gives me what? 2 pi over 3. Is everyone okay with that? All right. Now, once we're here, all right, so let's go ahead and now use our formula. Okay, and we're going to use the bottom one because it's the easiest one. Okay, so we're going to take r to the nth power. And what's r? 2. And we're going to take 2 and raise it to what is my power? 12. Times cosine of n times theta. What's my n? 12. And what's my theta? 2 pi over 3. Plus I times the sine of n, which is 12, times 2 pi over 3. You guys okay with that? Okay. Now, what is 2 to the 12th power? 4,096. Okay. Times the cosine of what is 12 times 2 pi over 3? 8 pi. Plus I sine of, again, 8 pi. Okay. Where does 8 pi fall? What does it correspond with from 0 to 2 pi? Where would 8 pi fall? Wouldn't it just end at 0? It'd be at 0 because 2 pi, 4 pi, 6 pi, 8 pi. Does that make sense? So 8 pi, isn't that at 1, 0? So what is the cosine of 8 pi? Is it the x or the y? X. So it would be 1 plus I times the sine of 8 pi. And what's the sine of 8 pi? 0. Sorry, 0. I keep writing sine again. Of 0. So then what is 4,096 times 1 plus 0 times I? 4,096. And wasn't it a lot easier than having to FOIL all that? Yes. Yeah, we had to do a little bit of work here calculating where the theta is, which is probably the hardest part of that. Right? All right, let's do it again. -1 minus I to the 4th power. Okay. So let's find our R. How do I find my R? A squared plus B squared in the square root. So what is my A? -1. What's my B? -1. Yeah. So -1 squared, 1. So 1 plus 1 is 2. So we just have radical 2 for my R, right? Okay. Now, let's find our theta. So tangent of theta would equal B over A. And what's my B? -1 over -1. So the tangent of theta would equal 1, right? You guys okay with that? And since my tangent is opposite over adjacent, which is 1 over 1, the same thing, what type of triangle do I have if the legs are the same? 45, 45, 90. So what is that in radians? we know it's a 45, 45, 90 triangle, the 45 is what in radians? Pi over 4. Okay. Pi over 4. Now, are we going to use pi over 4? I don't know. What quadrant are we in? Quadrant 3, right? So this pi over 4 is right here, but theta is the whole thing, right? So how would I actually get the whole theta? Add pi to it, yep. So theta would be pi plus pi over 4, which is 5 pi over 4. Yeah. Okay with that. So if you still have that chart from 4.4, that'd probably help you a little bit too, right? All right, so now let's go ahead and use our second formula again, okay, because that's the easiest one to use, okay? So R, what's my R? What did we figure out R was? The square root of 2, and we're going to raise it to what power? What's my N? 4. Times the cosine of N, and what's my N? 4 times my theta, and what's my theta? 5 pi over 4. Plus I times the sine of 4 times 5 pi over 4, because those are always the same. The cosine and the sine part is always the same. Now, let's do some calculation. What's radical 2 to the 4th power? Remember, radical 2 to the 4th is radical 2 times radical 2 times radical 2 times radical 2, right? What's radical 2 times radical 2? 2. Radical 2 times radical 2 is 2. So what's 2 times 2? 4. Wasn't too bad, was it? Times the cosine. What is 4 times 5 pi over 4? 5 pi. Plus I times the sine, again, of 5 pi. That never changes. Okay. Now, do our calculation. Where does 5 pi lie? Like our normal from 0 to 2 pi, 5 pi is the same as pi, right? 5 pi is going to be the same as pi, right? 5 pi equals pi. So what is pi as a coordinate? -1 comma 0, right? So what is the cosine of 5 pi? Is it -1 or 0? -1 plus I times, what's the sine of 5 pi? 0. So what is 4 times -1 plus pi times 0? -4. And there you go. Just found it. Any questions on that so far? So this one's a lot of remembering your trig functions, right? Okay, where they're located, that kind of stuff. Okay, and then just plugging into formulas. All right. Now, finding the nth root of a complex number. Okay, the definition. I forgot to include this, so we're going to add it. Okay. So the definition of the nth roots of it. Okay, if u equals a plus bi. Okay, then z will equal u to the nth power, okay, which is the same thing as a plus bi to the nth power. Okay. So how are we going to actually apply all of that? Okay, so finding those actual roots. For a positive integer n, the complex number, again, is that z equals r times the cosine of theta plus I times the theta. We'll have exactly n distinct n roots. Okay? So given by z to the k, so whichever root we're trying to find, it could be the 1, the 2, the 3, the 4, whatever, would be equal to n, the nth root of r, times the cosine of theta plus 2 pi k over n, plus I sine of theta plus 2 pi k over n. So again, that part never changes. Okay. Sine and cosine. This is where it gets a little long for us. All right. Okay. Where k again can be 0, 1, 2, 3, 4, all the way to n minus 1. Okay, n minus 1. All right, so let's look at this. Find all 6 roots of 1. Okay, all 6 roots of 1. Because we know values of 1 can happen all the time, right? Okay, so as we look at that, we're going to write our augmented, okay, equation. Okay, and that is, okay, z equals, we're looking at the 6th root of 1. Okay, so my r is 1, okay, times the cosine of 0 plus I sine of 0. Okay. And I don't know why I put theta, that should be 0. Sorry. Sorry about that. We're going to start at 0. Okay. Because we can have cosines of zeros. Okay. We're looking at that first angle of 0, theta being 0 in this sense. Okay. Now, in this case, when we look at looking for all 6 roots, my n is going to be 6. Okay. My n is going to be 6. We know our r is 1 because we're looking at the root of 1, right? And then theta obviously is 0 because we're going to start at 0. Okay. Now, looking at our formula. Okay, so our formula is z to the k, so the k goes up to 6. So z to the k, so in this case, we'll go up to 6, okay, is the nth root of r times the cosine of theta plus 2 pi k divided by, what do we say, divided by n? Yeah, divided by n, thank you. Plus I sine of theta plus 2 pi k over n, all right? So that's the formula from the other side. So RK, we want to go up to the 6th root, right? Where n, or where k, starts at 0, 1, 2, 3, all the way up to the n minus 1. So in this case, we're going to find all the way, we're going to do z to the 0, z to the 1st, z to the 2nd, z to the 3rd, z to the 4th, z to the 5th, z to the 5th is going to be our last one. Why? Because it ends at n minus 1. And our n is 6. So 6 minus 1 is 5. Okay. So as we look at this, let's go ahead and do z to the 0 first. Okay. So we're going to take the 6th root, so n radical r. So n is 6. So the 6th root of r, which is 1. Okay. Times the cosine, our theta is at 0, plus 2 pi k. And what's my first k? 0, right? Divided by my n, which is 6. Plus I sine of 0 plus 2 pi times 0 over 6. Which this one's actually kind of nice because if I take 0 times 2 pi, that's going to be what? 0. 0 plus 0 is 0. And 0 divided by 6 is 0, right? So really, and what's the 6th root of 1? 1, right? So really, when we're looking at z to the 0, it actually makes it a little bit easier because we're going to take 1 times the cosine of 0 plus I times the sine of 0, right? What's the cosine of 0? Where is 0 on our, right here, right? So is that 1 comma 0? So the cosine of 1 is, or cosine of 0 is 1. The sine of 0 is 0. So what's 1 times 1? Just 1. So z to the 0 is just 1. So the first term. Now let's go ahead and do it for when k is 1. So again, what's a 6th root of 1? I don't need to rewrite that. That is still just 1. Cosine, we're going to take 0 plus 2 pi times what? 1, right? What's 2 pi times 1? By 6. Okay, which I'll work in a second. Plus I times the sine of 2 pi times 1 over 6. And why did I get rid of the 0? Because anything you add to 0 is going to be the same thing, right? Are you guys okay with not showing that? All right. So let me ask you. We have 1 on the outside. What's 2 pi times 1? 2 pi. And what's 2 pi over 6? Simplify 2. 2 pi over 6 simplifies to pi over 3. All right. So pi over 3. What's the cosine of pi over 3? We need to write our triangle. So what is the cosine of pi over 3? Is it 1/2 or radical 3 over 2? Well, pi over 6 is 60 degrees, correct? Okay, so if we have 60 degrees, so the 60, 30. So cross from the 60 is radical 3, cross from the 30 is the 1. So cosine, is it the radical 3 over 2 or the 1 over 2? The 1/2, right? Plus I, so the sine would be radical 3 over 2. So 1 times all of that, isn't it just 1/2 plus I radical 3 over 2? And there's z to the first. Now we have to keep doing this until z to the what? Fifth. Okay, so let's do z to the second. So 1, and when I multiply by 1, do I need to keep that 1 anymore? It's going to stay the same. So are you guys okay if I eliminate that? So we have the cosine now of 2 pi times 2 divided by 6 plus I sine of 2 pi times 2 over 6. So we end up getting the cosine of 4 pi over 6, which is 2 pi over 3, plus I sine of 2 pi over 3. So now we just have to calculate that. So 2 pi over 3 goes this way, right? So 60. So now the only thing changes, instead of my 1 being positive, my 1 is negative. So what's the cosine of 2 pi over 3? Instead of being positive 1/2, it's going to be negative 1/2. But my sine of 2 pi over 3, isn't it still going to be a positive? So plus radical 3 over 2 pi. And where you put the I, I don't care if it's in the front or the back. Z to the third. So we have the cosine of 2 pi times 3 over 6 plus I sine of 2 pi times 3 over 6. So it's 2 pi times 3 over 6. Isn't that just pi? So we have the cosine of pi plus I sine of pi. So what's the cosine of pi? Isn't that just -1? The sine of pi is 0. All right. Are you guys getting the steps on this? Do you want to keep going? No? All right, I'll just give you the answers. So z to the 4th is -1/2 minus radical 3 over 2i, because now we'd be in quadrant 3, so both the sine and cosine would be negative, right? And then for z to the 5th would be +1/2 minus radical 3 over 2i. And now we'd be in quadrant 4, so just my y would be negative, which is my sine, okay? If you notice, most of the time, the values were always the same. It's just what's negative, what's positive from the two, okay? All right. And then example 9, the last one here, we're doing the cube root. So we just have to go to z to the 2, right? Because n minus 1, right? So our n is 3. So when we find our k goes up to n minus 2, right? Now, when we're looking at here, we're a little bit different in the sense because we don't have our values. We just have it as a complex number. So we have to find our r, we have to find our theta and that kind of stuff, right? So if we're looking at the sense, we know this is the coordinate of -2, 2, right? So -2, 2 is in what quadrant? 1, 2, or 3? 2. We're in quadrant 2. All right. So let's find my r first. So my r would be -2 squared plus 2 squared, which would be radical 8, right? 4 plus 4 is 8. And I'm going to leave it like that. And I'll show you why I'm going to leave that one like that since I'm simplifying. It actually makes it easier. Okay. Tangent of theta would be b over a, which is 2 over -2, which is the tangent of theta is -1. So since we have 1 over 1, we know it is going to be 45 degrees, correct? Which is pi over 4. Okay, you guys okay with that? Now, when we look at this for a sense, okay, if we're in quadrant 2, we're not using pi over 4, are we? Is that 45? Yeah, it's 45. Okay, we're in quadrant 2, so how do I get that? We got to subtract, right? So, and let's go ahead and just use the degrees. So I'm going to take 180 and subtract off 45. So what's 180 minus 45? So 135 degrees. Okay, so our theta is 135 degrees. All right, now let's go ahead and we'll do a couple of these. All right, so z to the k, remember, is n to r, right? The root to r. So in this case, we are looking for the cube root of the square root of 8. Is that correct? Now that looks kind of confusing, but if I take the cube root and the square root, isn't that the same thing if I put it in x or fraction form? 8 is the same thing as to the 1/2 power and then to the 1/3 power, correct? You guys okay with that? Could I reverse that and do the 8 to the 1/3 power raised to the 2nd power? And the reason why I did this is because what is the cube root of 8? What is the cube root of 8? Huh? 2. The cube root of 8 is 2. And then can I raise it to the 1/2 power? Can I take the square root of 2? No. So really the cube root of the square root 8 is really just the square root of 2. Does that make sense to you guys? Okay. And I'm going to do z to the 0. Let's go ahead and just keep starting from that. So this would be n to the r, which is square root of 2, times. Now we're going to do the cosine. What is my theta? What is my starting angle here? 135 degrees, right? Or we can do it, if we want to do radians, I'm going to take 135 plus 2 pi, which is 360 times k. And what is my k in this problem? 0, right? Divided by my n. And what is my n? 3 plus I sine of that same thing. I'm not going to rewrite that. Is that okay? All right. Now, what is 360 times 0? You don't need your calculator. What's 360 times 0? 0 plus 135? Huh? Okay. I was like, you don't need your calculator for that one. Is 0, right? And 0 times or plus 135 is 135. What's 135 divided by 3? Huh? 45. So we have the square root of 2 times the cosine of 45 plus I sine of 45. Hey, you guys can do that, can't you? What's the cosine of 45? What's the cosine of 45? Anyone? Radical 2 over 2 plus I radical 2 over 2. Because if it's 45, isn't my sine and cosine the exact same? Yes. Now, what's radical 2 times radical 2 over 2? What's radical 2 times radical 2? 2. 2 divided by 2 is 1 plus, and radical 2 times I, radical 2 over 2 is not just I. So z to the 0th is just 1 plus I. All right, let's do z to the 1st. So again, radical 2 is staying. Cosine of 135 plus 360 times 1, because now my k is 1, over 3, plus I sine of that exact same thing. I'm not rewriting that. All right, in your calculators, what's 130 or what's 360 times 1? 360. 360 plus 135. Okay, divided by 3. You guys get 165. Now, is 165 a special right triangle? It's 165. If I take 180 minus 165, what am I? What degrees? 15. Is that a special right? No. So guess what? You're going to use your calculators here. This is the reason why I went to degrees in a sense. Okay. What is, make sure your calculator's in degrees. What is the cosine? Let's go 4 decimal places. What is the cosine of 165? Yep. Plus I, and now what's the sine of 165? Good. And I put the I in front. It should be in the back now. And now, can you take each one of those numbers and multiply it by the square root of 2? Giving me a decimal? Yeah, so the square root of 2 times each of those would get me to what? So z to the 1st. So the square root of 2 times negative 0.9659 would be negative 1.3660. Is that what you guys got? And then radical 2 times that 0.2588 is 3660I. what you guys got? Okay with that? All right, and then z to the second, because I only have to go to 2. Why? Because my n is 3, so n minus 1 would be 2. Same idea. So the square root of 2 times the cosine of 135, my theta, plus 360 times my k, which is 2, divided by 3, which is n, plus I sine that same thing. I don't like to rewrite all that. Okay. All right. So let's go. We're going to get the square root of 2 times the cosine. What is 360 times 2 plus 135 divided by 3? You guys get 285? Yeah, okay. Plus I sine of 285. Now, if I go in my calculator, cosine of 285, well, let's think of 285. So that's greater than 270. So what's 360 minus 285? What's 360 minus? Because this would be in quadrant 4. Is that a special right? No, it's not, right? So we have to use our calculator. So we're going to go ahead and round again. So we're going to get the square root of 2 times, what is the cosine of 285? 588 plus, what is the sine of 285? Negative 0.9659. I. You guys okay with that? And now distribute the radical 2. And if we distribute the radical 2, what do we get? 0.3660 minus 1.3660 I. There you go.